Hi everyone, good morning. Today I'm going to show how to run LLM on Docker. Now, the primary means why we want to run an LLM on Docker. So Docker is basically provide an isolated containerized version for your application where and which helps you in distribution of your application. Okay, because it is a containerized version and as in an isolated moment. So all the means so if you want to run a model, then the model needs to be inside. If you are using a service, web service, that is another thing. But if you want to run it locally, then you should keep it inside the container. That is what I mean. Now, because and we all know large language models, the name itself has a large in it, are huge. So so means that was the reason, because I wanted to means if you have an application where we are using one model which is running locally and I want to distribute that application, I want to use a Docker image, because that is the best way most of the means enterprises are running, you know. But now the question comes, large language models are huge. I've already created one such demo. The link is in the description. That is for a small model, which was for survivability, um, employee survivability. So basically to understand that how long an employee will like stay in a company. And for that, I didn't need like any object means because it was a very small and it was a machine learning model and it was a very small model, so it was pretty easy to put it in a container and then distribute it. But as I said again, I'm repeating the same thing again. Large language models are huge. If we'll consider like 7 billion model, 7 billion parameter Llama 3.1 model, then it will means the amount of size of memory that it will take is around one no 7 to 8 GB, you know. Now, and that made me think that means so basically I wanted to research more on understanding um what are the different ways I can do this part. And that is why I went means the key concept that came into picture is model reduction. Model reduction technique is a huge and very popular techniques which has come into light after means it was there before as well, but it has become more it has come more in limelight after the LLMs started popping up. And what is model reduction? So basically reducing the size of a model. Okay, so if your model is like the size of a model is 5 GB, I want to reduce it to 3 GB or whatever is the amount of reduction. Obviously, with the reduction, there is a like cost associated with it. Cost in terms of accuracy. If you reduce a model, your accuracy will go down. But researchers have found of different means various ways to reduce, like architecture pruning, and there are other. But one quantifi quantization technique is the one which is being used like across the world right now and is most popular. So, and before we go into how we want to how this works, I just wanted to explain a very little about quantization of the model. And it's actually very simple. So if you think about quantization, so if you see this suppose you have a weight, and what quantization is, it is reducing the precision of your weights and biases. So weights or biases are numerical values, right? And numerical values can be stored in a floating format. And floating format is like 16-bit, 32-bit. So as you increase the bits, it is 64-bit. As you increasing the bits, it is increasing the precision of your model, and precision is directly proportional to the accuracy of the model. So here you see this continuous. So suppose this is your weight distribution, okay, and this is in some floating format. Let's consider this floating format 32. Now what we want to do is, as part of this quantization technique, we just want to reduce, means basically instead of this point over here, which is like 16 points. So suppose this is 16.32456, something is there on this side. Suppose this is 0. So it's like 16 point something. Instead of 16, I want to change into an integer. So 16.03253, I just consider it at 16. Now, this comes with a little bit of issue that suppose there is a 16.5678 and 16.123. So suppose this is 1.234 or 1.89. Both one you'll means map it to change it into an integer, both will be converted into 1, So rounding means if it is 1 point less than 1.5, both the values, then it will round to 1. So I will, means if you want to go into detail that how that so that is called quantization error, which is also very important while considering different types of quantization. So there are different types of quantization. So I will not go into that detail because that will require a whole another video. But quantization error is the way to identify which quantization is working or not, working better or not. So I would recommend, there are multiple research paper, but I would recommend this blog post from Martin Grusten. So this blog post is holy grail, and these images are also from those blog posts. It will give you a whole information about what these quantized model are. And I will tell you, so now, and I have given a little bit of example, like suppose your model weights range from minus 10.8 to 10.8, and we are doing symmetric quantization. So and you want to change it to into 8-bit integer. So 8-bit integer, int 8 is like 2 to the power 8, and then and you have mapped the max value. So what will be the value of 5.47? It will be 64. 0 is 0 because this is symmetric quantization. So what will be the value of 5.47? It will be 64. How? So this is the formula. The formula is very simple. We first need a scaling factor. So a scaling factor basically gives you, just give me a second. I will show you the formula. Yeah, the formula is, so first we have to find the scaling factor. The scaling factor is S is equal to 2b minus 1 by alpha. Now b is the bit, and so I want to convert it to 8-bit, and alpha is the highest value, so that is 10.8. So scaling factor is 11.6. Now just multiply your value, which is 5.4, to 11. Sorry, with 11.76, which is the scaling factor, and you will get the value. So it's approximately like 64. You have to round this value. So once you round it, it will come to 64. And that is how you got the 64. So this is, like a kind of a normalization technique in which you convert the value from whatever you have over there in your weights to a 8-bit integer format. So once you have these things, okay, so just give me a second. Yeah. So this was the way how these quantized model. So once you go to the Hugging Face, you will see there are different models which are into GUF and GGML format. So what they actually mean, how they are different. So this is how they are different. They have been quantized and reduced to lower bits. So, and there are different type of conversions. It can be reduced to 8-bit, 6-bit, and uh, even 4 bits, and even 1 bit. But this is directly proportional. So this quantization error, which will determine how your model is behaving after applying this technique, is proportional to the number of bits. So um, means actually it's inversely proportional to your number of bits, because as you reduce the bit, quantization error will increase. So and that is why I wanted to show that what is the difference between normal model and a quantized model. So now, once you have learned about the quantized model, obviously, if you want to learn more, I just gave you like a very high information. Go through these links. These links are very powerful. Means they will give you a lot. Now, second thing is Ollama. So Ollama is just an open source tool, which basically simplifies how we deploy and use models locally. You know, so and now our use case was to run a LLM in a Docker. So to run an LLM in a Docker, what you have to do is you have to just do 2 steps. One is run this Docker. So obviously there's a prerequisite that a Docker is already installed in your system. Okay, but after that, um, run this Docker command. So what it will do, it will start running Ollama in your Docker at localhost 11.434. So as you can see, Ollama is already running at my localhost 14, so 11.434. So now I will go back. So as the Ollama is already running, so what I have done, I have just simply created a very small code to, I will explain, means what you have to do and which model to run after that, or how to download the model. But I wanted to use Phi 3 because it is the smallest but very powerful model. So let's just run it, because it takes like little time, and I will show you why it will take so much time. So as you can see, Ollama is running at this port. So this is my Docker desktop. You can also download it. I'll just stop this. And this is all, and here you see I have allocated, so I have only 8 GB of RAM, and you will see that the memory has already shot up, and CPU uses is also very high, you know. So, but let's just go back to our system. So how, okay, now, so first thing is, once you install it, it will install the Docker image and start running it on your 11.434 like port. Once you have that, now the next thing that you want is a large language model, which needs to be installed. So for that, there is a documentation which you can refer. So I think it's available over here. Yeah, these are the different. So this is Ollama website. These are the different models that is available, and all you have to do is just write the name of the model with the command in your terminal, and it will start running it. Start downloading the model. So if I'll go back, yeah. So here I just wrote Llama 3. Llama 3 is very popular. That's why I wrote it. But if your system is like has less CPU, 8 GB CPU, if you have less than 8 GB CPU, I would not recommend to do this. Okay. But if you have like more than 8 GB CPU, then you can run this. So if you have 16 GB CPU, go for Llama 3. If you have 8 GB CPU, I would say use 553. So let's just go back to our system, and yeah, see, it's still running. So it takes like so you see the CPU uses has shot up to 900% because running these models take a huge toll on your system. So that's why it will take some time to get and give us the result. Now, while we are doing this, there is another thing that I wanted to show was just give me a second. Uh, how we can use it with ServiceNow. So if I'll, yeah, so I've created this, I mean, I've used one of the flows that I've already created, but used it a little bit in our system. So once we have this Ollama and Ollama Docker server running, so it is basically running on your local host at 11.44.34, which you can call with ServiceNow using any means. You have to install a mid server on your machine, on your local machine, and then you will be able to call this local host. Once you have that uh, like installed, simple REST message directly to this will connect you with the Ollama service. Now, why Docker? Again, I will tell you, because it is means you just need 2 steps to download it and install it. That's it. So if you want to run this on a server which has a GPU, it is like it will be very fast and it will be immediate. So that is the reason for Docker. Our system is slow. That's why it is taking some time. Next thing that I wanted to show was this part, Open Web UI. So what you have over here is so Ollama also means there are multiple open web UIs, which are interface very similar to ChatGPT, OpenAI, and you can use them to train or test your model. So let me show you that as well. So if I'll go back to my Safari and yeah, so here you see this is running on localhost 3000. I will also provide the link to download this. So here you can directly, so you can interact with your Ollama directly from here. So here you see I've already provided the 5.3 latest is the model that I'm using, and a, a, there are different attributes associated with it. Look and feel is very similar to OpenAI. So okay, it's still taking some time. So meanwhile, um, so let's just, yeah, as you can see, it is taking a lot of time, and it has okay. We got the answer. So it takes on my machine, it takes like 2 minutes or something. But here's the answer. Docker is an open source platform that allows you to create, a deploy, and run application by using containers, and containers are lightweight. So it has provided the answer, which is pretty good. And yeah, if you have a like bigger, powerful machine, it will run very smooth. And this is the whole demo. If you have any questions related to any of this, please let me know. I will be very happy to provide you the answers. I'm not showing you the ServiceNow part because once you have the service running, up and running, how you want to use the service, it is up to you. So I just gave claims is one of the use case which I will create in future, but not right now. I've not created it. But this is one of the use case where you can just send all your data and send it to your server and get the response that whether the claim that user is making is fake or not.